Hello everyone, myself Bhuvanashri VS. I am currently pursuing my civil engineering in SVC Bengaluru. Today we will be discussing about principle and working of Rankie cycle. Introduction to Rankie cycle. The Rankie cycle is a thermodynamic cycle used in power plants to convert heat into mechanical work. It is a practical and efficient way to generate electricity from heat sources such as coal, natural gas, or nuclear energy. The cycle consists of four main components, that is, a boiler, turbine, condenser, and a pump. Principle of working. The Rankine cycle operates on the principle of converting heat energy into mechanical work. Heat is added to the working fluid in the boiler, increasing its temperature and pressure. The high pressure steam then enters the turbine, where it expands and drives the turbine blades, producing mechanical work. Rankine cycle process. The Rankine cycle is the process widely used by the power plants such as coal-fired power plants or nuclear reactors. In this mechanism, a fuel is used to produce heat within a boiler, converting water into steam, which then expands through a turbine, producing useful work. The working fluid then exits the turbine and enters the condenser, where it is condensed back into liquid. The condensed liquid is then pumped back to the boiler, which completes the cycle. The cycle continues as long as heat input is provided to the boiler and the working fluid is circulated throughout the system. Efficiency of Rankine cycle. The efficiency of Rankine cycle is determined by temperature difference between the heat source and the heat sink. Higher temperature differences result in higher efficiencies. Improving the efficiency of the Rankine cycle is essential for maximizing power generation and reducing fuel consumption. Components of Rankine cycle. Boiler. When heat is added to the working fluid to generate high pressure steam. Turbine, which converts the high pressure steam into mechanical work. Condenser, which condenses the steam back into liquid form. Rankine cycle on TS diagram. The Rankine cycle is often represented on temperature entropy, that is TS diagram. The diagram shows the various states of the working fluid throughout the cycle. It helps engineers to analyze and optimize the performance of the Rankine cycle. Types of Rankine cycles. There are several variations of the Rankine cycle, including subcritical, supercritical, and ultra supercritical cycles. Each type has its own unique operating conditions and efficiency characteristics. Engineers select the most suitable type of Rankine cycle on the specific requirements of the power plant. Advantages of Rankine cycle. The Rankine cycle is widely used in power generation due to its simplicity and efficiency. It can utilize a variety of heat sources, making it versatile and adaptable to different fuel types. The cycle can be optimized and improved through advancements in the technology and engineering practices. Challenges of Rankine cycle. One of the main challenges of the Rankine cycle is minimizing energy losses and improving efficiency. The cycle requires careful design and maintenance to prevent issues such as corrosion, scaling, and leaks. Environmental concerns such as greenhouse gas emissions from fossil fuel combustion also pose challenge for the Rankine cycle. Applications of Rankine cycle. The Rankine cycle is used in various industries including power generation, manufacturing, and transportation. It is employed in steam turbines, geothermal power plants, and waste heat recovery systems. The cycle plays a crucial role in meeting the global demand for electricity and reducing reliance on fossil fuels. Global impact of Rankie cycle. The Rankie cycle plays a significant role in the global energy systems, contributing to electricity generation and industrial processes. As countries transition towards sustainable energy sources, the Rankie cycle will continue to be a key technology for power generation. Collaborative efforts and international partnerships are essential for advancing the deployment of Rankie cycle solutions worldwide. Environmental considerations. The Rankie cycle can contribute to environmental sustainability by utilizing renewable energy sources and reducing emissions. Integration of carbon capture and storage (CCS) technologies can mitigate the environmental impact of fossil fuel combustion in the cycle. Increasing awareness of climate change is driving the adoption of cleaner and more efficient power generation technologies like the Rankine cycle. Economic viability of Rankine cycle. The economic viability of the Rankine cycle is influenced by factors such as fuel cost, maintenance expenses, and regulatory requirements. Life cost Life cycle cost analysis and financial modeling are used to evaluate the economic feasibility of implementing Rankine cycle power plants. Advancement in cost-effective technologies and financing mechanisms are enhancing the competitiveness of the Rankine cycle in the energy market. Conclusion. The Rankine cycle is a fundamental thermodynamic process that converts heat into mechanical work for power generation. Ongoing research and innovation are driving improvements in the efficiency, sustainability, and economic viability of the Rankine cycle. By understanding the principles and application of the Rankine cycle, engineers and stakeholders can contribute to more sustainable and energy for future.